students, and welcome back to another topic in science class. This week, we are going to be discussing what are called the rates of reactions and the energy of reactions. And this particular topic helps to explain the how and why certain chemical reactions occur in certain ways. So without further ado, let's get busy in our notes here for today. And we only have a couple days of notes this week, today and tomorrow, and that's it, because we're going to be doing some activities as well. But let's begin with rates of reactions. And in particular, let's discuss this thing called the collision theory. You will be watching, if you haven't watched it already, a video of two school children trying to get together for a dance. And throughout this video, it offers some different ways in which these two could get together. And I think it does a pretty creative way. It uses a pretty creative way of discussing how the rates of chemical reactions can change. Because as you know from last week and the week before, chemistry is love. The love of chemistry, or the chemistry of love, is powerful. But right now, let's talk about the collision theory. You see all of these smiling faces on the screen. These smiling faces are illustrating or representing the various molecules of matter in motion. And without matter in motion, there would be no chemical reactions at all. Now, what the collision theory states is this: the rate or speed of a chemical reaction is determined by molecular collisions. Not only the number of molecular collisions, but also the speed at which those collisions take place. That's what the collision theory is all about, that it is basically the kinetic energy of molecules bouncing into one another that allows, enables, and creates the conditions under which chemical reactions take place. It all has to do on a molecular level and things bumping into one another. Now, there are different factors that affect the rate of reaction, and we're going to go over 4 of them today. The first factor that can affect the rate of reaction is something called concentration. No, not this type of concentration, although it's not a bad idea to do some concentrating when you're studying science. But concentration in the sense of the amount of a substance in a given volume. Now, some of you have known me for quite some time, and some of you have known me long enough to know that I am a self-professed chocoholic. I love chocolate. And some of you have heard stories of me when I was younger and how I would make my chocolate milk after school each day. Yes, I'd come home from school each day and I'd have a little snack of either sliced apples or carrots or celery, and I'd wash it all down with a nice glass of chocolate milk that I would make myself. And back in those days, we had like cardboard tins of, I think it was like Nestle Quick Mix. It was a powdered chocolate milk material that you'd have to pry off the metal lid and then scoop out this brown powdered delight, put it into the milk and stir it around, and voila, you had chocolate milk. I don't even know if they have that anymore, do they? Because I haven't had that in years. But I can recall reading on the directions that it would take 2 heaping teaspoons of chocolate mix into a full 8-ounce glass of milk, stir it and swallow. Well, I never followed those directions because the concentration of chocolate in that milk was way too weak for me. So rather, what I would do is first I would use tablespoons, which are larger than teaspoons. And if it said 2 spoons, forget that. I'd make it 4 or 6 or sometimes even 8. I would put so much chocolate mix into my milk that after I would stir it around, I had to hold on to that spoon to scrape out the chocolate syrup on the bottom of that glass when I was finished with my really dark, chocolatey milk. Are any of you as bad as me when it comes to the concentration of chocolate? My mouth is watering for some really thick and rich chocolatey chocolate milk even right now. Oh boy. My favorite kinds of ice cream are all chocolate-based ice creams too. I just love chocolate. Okay, moving right along. How does this affect the rate of reaction? Well, you can probably imagine me as a kid drinking a super concentrated glass of chocolate milk, contrasted with me drinking just a regular glass of milk. Which glass do you think caused me to become a little bit more hyper in my behavior? You guessed it. Yeah, that super sweet, rich, delightful, chocolatey chocolate milk had so much sugar in it that it would react with the chemistry in my body and give me an enormous amount of quick released energy, and I would just go bonkers running around outside. And this was long before the days that people recognized hyperactivity disorders in children. I was just naturally hyperactive when I drank chocolate milk that was just too chocolatey. Because there was a chemical reaction that took place in my body because of the overabundance of sugar, basically. I overdosed on sugar when I was a kid. I admit it. I'm not proud of it, but I do admit it. And it wasn't the healthiest thing for my body, I have to tell you. But increasing the concentration of chocolate increased my rate of activity. I'm bouncing off the walls because of all of that chocolate. So, in the context of chemical reactions, the greater the concentration there is of something, there's going to be more collisions taking place between the molecules of matter. And as a result, a chemical reaction, no matter what it is going to occur more rapidly. So increasing concentration will increase the rate of reaction. Brings us to number 2. Number 2 is altering the surface area of something. Now, what exactly does that mean? Well, surface area has to do with describing the external or the outside area of the surface of something. So imagine you had a cube. I'm just looking around the room here for a cube. I don't actually have a cube here. I apologize. But imagine you had a square cube. And this square cube like the picture of a square here. Imagine this were three-dimensional, like a rolling dice. You could take the area of each side of that dice and multiply it by 6 because that's how many surfaces are exposed to the outside. Now take that same cube and cut it in half and cut it in half again. You're exposing additional sides to the outside. I won't even ask you about numbers here, but can you imagine what happens to the surface area if you chop up a block? Are you increasing the amount of area exposed to the outside? Are you decreasing it, or does it not change? What do you think? Well, it increases. Every time you chop up a block or any piece of matter, you are increasing the surface area. And by increasing the surface area, you are exposing a greater number of particles. And the more particles there are exposed to another substance, another chemical, the faster the chemical reaction is going to take place. So let me give you a quick example. Let's say I had spicy food. Now, my body just doesn't handle spicy food. Maybe you like atomically hot spices, not me. I don't even put regular table pepper on my food because my body just can't handle spices for whatever reason. But let's say I eat spicy foods. Big mistake. I'm going to have an upset stomach. I'm going to have heartburn like you would not imagine. And so, what might I turn to? I might turn to an antacid, those little chalk-like tablets that you chew and you chew and swallow. See, I'm getting indigestion just thinking about eating spicy foods. So I would reach for some antacids, chew them up, swallow them, and hope that they help to neutralize the acids in my stomach so that I feel better. Now, would it make sense for me to take those tablets and just swallow them whole? What do you think? Well, the answer is no. You may or may not realize this, but digestion is a chemical process, and digestion begins in the mouth. And it's why you have teeth. Digestion begins with your teeth. It's called mechanical digestion. Chewing your food is so important because you are breaking down whatever the food is that you've put into your mouth. You are breaking it down into smaller and smaller chunks and pieces. And in so doing, you are increasing the surface area of that food so that the digestion in your body, which is a chemical reaction, can take place more rapidly and more easily and put less strain on your digestive system. Digestion begins with chewing your food. Now, I've walked through the cafeteria in the school on more than one occasion, and I've seen how some of you tend to inhale your food so quickly that chewing does not take place at all. Let me give you some friendly advice. If you want to avoid later in life having to chew antacids a lot for your upset stomach, chew your food slowly now. Chew before you swallow, because digestion is chemistry. Remember that. And chewing increases surface area. Actually, this looks like chicken dumplings and peas, doesn't it? Boy, I'll tell you what. Cracker Barrel makes a really good chicken dumpling, by the way. Now, my mouth is watering a little bit for chicken dumpling and peas. But that's not what, I don't think that's what they are, but it almost looks like chicken dumpling and peas, doesn't it? Yum, yum, yum. Okay, let's move on. So you get the idea of surface area, right? All right, number three. Number three is temperature. Temperature is a measure of a particle's energy of motion, or kinetic energy. Now, here's the deal. If you look at these two diagrams here, the one on the left is illustrating a high temperature, the one on the right a lower temperature. And you can see that by the length of the arrows. The longer the arrows, the faster something is moving. The shorter the arrows, the slower something is moving. And based on the collision theory, the more collisions that take place, the faster the chemical reaction. So, if you heat something up so that the arrows are longer, which indicates something is moving quicker, you're going to have a greater number of collisions taking place between molecules of matter. The slower something is, the slower the reaction. The faster something is, the faster the reaction. In fact, all of you, I would imagine, probably have a thermodynamic device in your home to slow down the chemical reaction of decomposition. Yes, I'm sure you do. It's called a refrigerator. Think about it. A refrigerator and or a freezer, what does it do? It lowers the temperature of your food. Why does that help keep your food fresh? It's because food spoilage is a decomposition chemical reaction. Rotting food is chemistry. And nobody wants to eat rotten food. So what do? We slow the rate of decomposition by lowering the temperature. The lower we make the temperature, the slower the reaction of rotting. So frozen food will last a lot longer than food left on your kitchen counter at room temperature. Why? It's chemistry, folks. Lower temperatures will lower the rate of reaction. Higher temperatures will increase the rate of chemical reactions. It's just a matter of chemistry. And that brings us to number 4. Number 4 are catalysts. Now, these might be the most difficult to understand, perhaps, but we'll be doing an activity to illustrate catalysts. But I think I'll be able to give you a couple of examples which will help you understand. Catalysts are substances that can change the rate of a reaction, but are not changed themselves. What do I mean by that? Well, have any of you ever been egged on by someone else? You know what that phrase means? Have any of you ever been provoked by someone else? Maybe between you and a third party. Let's say there's person A, B, and C. And person A is you, person B is a friend of yours, and person C is this bystander acquaintance. And person C starts telling you stories about person B doing something that, well, aggravates you, person A. And then they tell person B something that aggravates them about you. They're a troublemaker, basically. And this troublemaker, this person C, is telling stories to you and your friend to antagonize the two of you to have a fight with one another. Have you ever experienced something like that? Well, that person C is a catalyst. They're not your friend. They're not the other person's friend. They're just a troublemaker looking to break up your friendship. Well, don't let them do it, folks. Don't let them do it, okay? Because this substance may want to change the rate of reaction or change your relationship, but they're not changed themselves. They're still just a nasty person. Boy, oh boy, they're not involved in it at all. Well, let me try and give you another example here. Here's a picture of, oh golly, a pile of dirt. I don't know how this has to do with activation energy. Let me go on to another example. I don't really care for that one, okay? Let's look at this, a chemical reaction. Here we have a chemical reaction that takes place between H2O, water, and CO2, carbon dioxide. And the products are glucose, C6H12O6, and oxygen. This should be a familiar chemical reaction to you, especially given the hints in green and red. Do any of you know what this is a chemical reaction of? If you said photosynthesis, you're absolutely correct. Photosynthesis, as illustrated by this chemical reaction, and by the way, some of you may see this equation and recognize that it is not a balanced equation. I'll give you a bonus point if you take this equation and you balance it for Friday's quiz, by the way. So take that as a bonus challenge to you. Balance this equation for photosynthesis. But what I've written above and below the arrow or the yields symbol are two catalysts, chlorophyll and sunlight. Without chlorophyll and sunlight, this reaction does not take place. But in the presence of chlorophyll and sunlight, this reaction between water and carbon dioxide does take place and produces sugar and oxygen. But chlorophyll and sunlight aren't directly involved in the reaction chemically themselves. These two things are called catalysts. Catalysts. Let me give you one more example for those of you that might be automotively inclined. Have any of you ever heard of a catalytic converter? A catalytic converter. What in the world is a catalytic converter? Some of you might know what a catalytic converter is. It's a device before the muffler of an internal combustion engine that takes out nasty gases like carbon monoxide from the exhaust system of a vehicle. Well, how does it do this? It does it using a catalyst. Thus the name catalytic converter. It uses a catalyst, and that catalyst is a precious metal, platinum. Platinum is a catalyst in the internal combustion engine that removes carbon monoxide from the exhaust to make the exhaust that much safer as it comes out the exhaust pipe of your vehicle. So here we have gone over today the 4 factors that can affect the rate of reaction, and you can have more than one of these factors affecting a reaction at the same time. For instance, if, my antacid condition, okay, I got heartburn. If I chew, I am increasing surface area. If I drink warm milk, perhaps, I don't know if that would help. I've never tried it, but I'm not really a big milk drinker unless it's chocolate milk. But if I increase the temperature as well, it will quicken the chemical reaction as opposed to drinking like ice water. Gosh, I've never tried that. You know what? I might actually, no, I don't want to upset my stomach. But if any of you like spicy foods, maybe you could try that as an experiment. Alter some of these different factors affecting the rate of a chemical reaction. So we'll finish up our notes tomorrow, and we'll talk about the activities that we'll be doing later on this week. So until then, bye-bye.